Let's talk about how to estimate how much energy would be saved by replacing a less efficient fuel-burning appliance with a more efficient fuel-burning appliance. Customers want to know this all the time, and it's a legitimate question. So, we need to be able to estimate that. This is efficiency improvement savings. I'm going to teach you how to do this so you don't have to memorize any equations. What you need to figure out in order to write any equation is what stays the same from case 1 to case 2. What remains the same? Okay, the efficiencies are changing, or the efficiency of the appliance is changing. The input to that appliance is going to change. It better, because the input is the energy you're paying for. The input into a furnace or a water heater is what you just paid for. That's the energy. So we want that to change. We want to save energy. But what stays the same from the before case and after case is the output of the furnace, for example. So we're not changing we're not adding insulation or anything like that in this particular calculation. So it takes the same amount of heat to heat the home or other building before you make the change and after. That's how you know how to set up your equation. So in this case, the output of the furnace after you make the change is equal to the output before. That's how much heat it takes to heat the home. Now, what do we know? We know that the old furnace is about 70% efficient. We're replacing it with a 95% efficient furnace. And we can estimate through averages how much fuel was used to heat the home in the past few years. So say take 3 years and average them, and you come up with 600 therms. You know that from the energy bills. That last year, the year before that, they're using about 600 therms to heat the building. So let's just start with what we know, the givens, and what we know about the situation. The heat that's required now is the same as the heat that was required before. Well, the output of an appliance is the efficiency of the appliance times the input. And the input's what you pay for. So output, E of the new, the efficiency of the new furnace, times the input of the new furnace, that's what we don't know, is equal to the efficiency of the old furnace times the input of the old furnace. So what we're after is this input 2. How much gas or other fuel are we going to have to put into our new furnace? Well, to get that by itself, you just divide by E2 on both sides. You end up that the input of the new furnace is equal to the efficiency of the old one divided by the efficiency of the new one times the input of the old one, which we've said is average 600 therms. So let's write that out and figure it out. So what we get then for the input into the new furnace is 0.7 divided by 0.95 times 600 therms. Punch that into the calculator, get 442 therms. Now that's the amount that you're going to pay for after you make the change. And to get the savings, you just take the amount that you had to pay for before, which was 600, minus the new input, to show that we estimate that you'll save 158 therms per year by replacing a 70